Okay, so we have returned to more code development here. Last video, we worked on this thing. This is a sentry gun. Yeah, not much exciting going on with it. It's not much different than existing sentry guns, and from the last two videos I uploaded, not a lot really going on with it. It just fires and works. Key point to note, the green and blue lasers you were seeing are debug lasers. There is a red laser hidden in there, but it's really, really hard to see. We're going to work on making it easier to see, and we're going to work on debugging the aim code. As you notice, the blue laser doesn't quite render from the front of it. It renders kind of wherever it wants to do, and the same with the red laser is you just barely saw. They don't render properly. This actually has nothing to do with the render code itself. This has everything to do with the position logic of the sentry gun. So we're going to spend time debugging it some more and getting it working. Quick side note, I did go fix the handgun render. So we got this. It does actually render right. You can barely see that blue laser, but you can strongly see the green laser. If I go to third person, you can see that blue laser. Blue laser is what is actually used to check to see if I hit the target or not. Eventually, the green laser will also be used. They'll be like tied together. But thing to note that these aren't actually the real lasers that get fired. There's a ray trace that actually fires, and all that happens is these lasers just kind of show the general path where those ray traces went. They're not precise, but they do work. I have coded now offset positions for the handgun and everything, so a gun can now control where that green ray trace shows up at. So we can make it go a little higher, a little lower, and eventually we'll have a system where if I right-click aim, it will change positions in various things. There is quite a bit of code I do have to work on and make things function appropriately. There is now a code to handle the ejection angle and position of shell casings. This will, of course, need to be handled better, but the code is there. So if a gun wants to set the ejection port, he can. If he wants to set the ejection vector, which will be the velocity, he can do that as well. And that's pretty much it on that segment. Um, but this is fixed now. The aim code is now sitting inside of each player gun object. So as I noted, we transitioned over to using the user object for things. So we got the position in here, but if you go to the user, we get the projectile spawn offset. So this is where the player's hand would be, or if it was an entity holding the weapon, this would be where the entity's grip is. It doesn't have to necessarily be a hand. It could be teeth. It could be whatever. It doesn't matter as long as you return an appropriate value. Same for the get entity aim. You return appropriate value and it works. So this all ties in properly, and it works. I mean, I'm surprised how well it actually works and handles well. This, of course, ties back into the sentry gun. So the sentry gun is providing proper aim values now, except that its aim is actually off to start with. So to debug this, we're actually going to recycle the debug code for the ray trace we are already using right here. And we're going to use this to render from the center point to our expected aim point. We'll do that with like a yellow laser or something. We'll make collars. We'll figure things out. And this will allow us to debug all of our information. This is primarily what I wanted to show off, is more ways to debug things. This video is not exactly about just working on the sentry gun. Let's see, there's the sentry right here. So we want to run a laser to replace our center point render and this here. So we're going to run a laser for this. So we've got a hand position, which is going to be our exit point. So this will be hand. Why are we calculating it? Whatever. We'll put this up here. Not much of a need to question why things are working this way. Just I coded it at some point. That's all that really matters. And then we'll pass in center point, and this is what we're going to use to actually handle everything. In this case, we need to do this as a world. And man, those slimes are probably some of the most annoying noises I can hear. And we'll just pass in this. So that'll work. And for the collar, we'll make this one. Now we'll see if a black laser renders. I don't think I've rendered a black laser in a while. Let's see what this looks like. Looks like nothing, pretty much. That means either the position value or something's wrong. Make this 10. Probably the time's wrong. No. Something's not running properly with this. Packet spawn. Oh, we're running packet spawn stream. That's what we're running over here. Spawn stream. Start point, end point. We're using number 2. I feel like there actually is something weird with this. No, that's pretty. Oh, type equals 2. So this data is actually a type variable. I'm still not seeing my laser. And this could be a weird render glitch. I feel like that's actually what's happening, is that the particle system has a collision detector on it. If type equals 2, we're rendering an FX beam with a collar. This doesn't make sense. This should work. Let's try a different color. Magenta. When you're really bored. Ah! It's working. Okay, so that's going to give us a really decent indicator of where our center point is versus where our spawn. It's actually kind of really lousy. It works. I'll have to write some better code here. The thing with the beam render was legitimately just designed for 2 purposes in use. It was designed, actually 3. Designed for the sentry guns to use, designed for Calculavius lasers to use, and was designed to be a replacement for the MFS beam render. It never got replaced on the beam render, but yeah. Oh, we can tell the pitch isn't updating quick enough. The eye isn't really doing much better either. I can't tell if that's a laser's fault or something. Anyways, the next thing we want to do is we want to run another one of these. This time we want to run this to our aim-ish direction. And the goal is to get these to overlap with each other. So this will be get... why is get aim pointed? Oh, let's get aim at. That's not what I want. I want to get entity aim or something. There's a method. Where's here? So get entity aim. Okay, and this needs to be some different color that isn't magenta. Yellow. Yellow works. Okay. This is the problem we're running into. See where the laser actually is? That is complete. Oh my god, look at it bounce everywhere. Means there's something seriously wrong with some of the code if it's bouncing. Okay, so we want another beam. This new one is going to be if the target's not null. So we're going to go if if target doesn't equal null. Then we want the hand position to be pretty much the target. Actually, you know what? There's a targeting vector. So it'd be target point. Oh, where is target point calculated? It's here somewhere. It's called aim point. So we're going to go if aim point doesn't equal null, then we're going to just do aim point. Okay, so aim point works perfect, which is what I expected, because if it didn't work, it would we wouldn't be able to do anything. We need a different color for this. I feel like running green or something. You know what, we're going to turn off this line right here. We don't need to debug. I don't need to debug the ray traces anymore. I'm going to break the tile and reset it. Oh, okay. I haven't done the pick block code yet. So when it starts off, it seems to be working. The aim is off by a lot, and the aim needs to be a different color. We're going to make this blue. I like using the yellow for the targeting. It works, because then we don't have to worry about it overlapping with the red laser when we go to fix it a bit. So, blue laser is our actual aim. We need to then render current aim. So we want to get center, and we want to then do... Actually, get entity aim is our current aim. So, oh shoot, I closed the sentry again. And of course it didn't open me up on the line I was actually still on. So we want to add actual aim. So aim.toPos. And we're going to render this as cayenne. Will be a good color. So our current aim and our expected aim is what we're trying to rotate to. Don't work. Neither of these dudes work. The odd thing is, the sentry gun does rotate to face the target, so the rotation values do work. And the bullet off spawn works, or bullet offset works perfectly, which we calculate here. And that's because we minus a lot of numbers from it. Because it wasn't correct. Now this begs the question, is the rotation broken? So is the rotation math broken, or is the vector math broken? So what we're rendering is vector math. We're rendering the vector, so we're taking the rotation, we're turning it into a vector. So is it, seeing as these two almost match each other perfectly, they're within literally one rotation of each other, which is the reason why they're not always overlapping. Is the sentry gun actually doesn't care if it's perfectly aimed. It goes, am I within one tick worth of rotation? And if the answer is yes, it'll shoot. That's the reason why you see the laser go like that rather than being perfect on target. The reason we don't do perfectly on target is you can't. You actually can't rotate perfectly. It would take too many ticks. If you've ever heard a math teacher go, okay, I want you to divide this, I want you to take the distance from here to the door and always walk half that distance. You could walk half that distance for the rest of your life and still never get to the door. At least mathematically. Reality of it is that, well, screw math in certain aspects. So we're off by 135 degrees. Plus we're negative. So something's wrong with our calculated system. And it's actually this right here. Target position. Actually, I think it already does this. To either angle, so we want to sub-target to either. Okay. Let's switch these two and see what happens. In the name of science. Okay, now we've 180'd ourselves. And the blue and the thing are still completely messed up. Oh, wait. What was that? You know what we need to do now? I need to force my aim point to something. This is how we correct for issues like this. So we want to go aim point equals new pause, or we want to go center.add 0 or shoot. How do we do this properly? The code's not designed to test it this way. So we want to test vector code is what we want to do. So we're just going to have to force some values here. So we want to grab this stuff. Actually, we want to leave that there. So we want to grab this. We then want to come up here. We want to set our aim point, and we want to set, we want current aim to equal, our current aim dot set yaw to 0, and we want current aim dot set pitch to 0. So we want to baseline our stuff, and then this way I can then go 0.0 dot -1, I think, because 0 should be north. Okay, so we have a yellow laser. As you can see, it's going to snap on us a couple times. Aim point, center.add, try -10. Okay, we are facing north. Good. At least we know 0 is north. Now we just need to get all of the lasers to point the same goddamn direction. And we need to do this real quick so I can see these lasers. So we're going to add 0, we're going to add to the height of all this stuff. This way the lasers don't operate. So this is our hand position, which is our bullet offset. Okay, so it's pointing in the right direction as our yellow. So if our target is set that way, it does sort of work. What we also want to do up here is force the target to null. Target equals null, because then it'll stagnate. Here we go, just snap. Okay, so I can't see the dark blue laser, so we need to raise it by a certain point value. So we're going to add 0.2 to these, and then we're going to add 0.3 to this one. And we're going to leave aim point alone. Okay, blue is the right direction. What is this thing? Our magenta, or not, that's not magenta, that's cayenne. Our cayenne is our aim. So this is what we think we need to be aimed at, which is this variable right here. If we force our rotation right there to 0, 0, it works. It's perfect. Our current aim is not. So our current aim is decided off of our aim point minus this and clamped. So let's try returning it back to center, and then minus our aim point. Oh shit, they're all the same. That was not expected. Take a picture of that. Rainbow for the win. So what broke in this system? If we reset everything to 0, everything works. Now if we, let's say we want 80, which means this would be positive 10. So if we go 180 degrees the other direction, both of our aim points are wrong. So it thinks that is 180 degrees, is that direction. It's got to be this clamp to 360. So let's pass this junk and get rid of it. Okay, that didn't work. So let's we can't normalize. So we got to do this the hard way. So we want to do this dot subtract aim point dot normalize dot to Euler angle. Still not changing anything at all. We're still off. Why are we off for? How do these work? What is yaw? How is yaw used? It's got pretty much the same math values and absolute difference within. Oh shit, these are radians. For those who don't understand what I basically just said, been rotating incorrectly. Oh man. Wow. How do I fix this? That's the dumb thing too, is our clamp to 360 method assumes we're running in derpy derps. Our lerp doesn't give craps. Our move towards doesn't give craps. Our move yaw doesn't care. Like, none of the other methods care if we're running in radians or degrees. Our clamps though assume we are. So I've got to go figure out where this is used. Okay, it's probably why the translation never works on this thing. Oh man. There's a couple spots where this is not running correctly. Huh, luckily that's not even used. Could explain why this never worked. This is a missile display object which we use to actually display missiles. You know what, we're just gonna fix it. Oh man, the inserter arm uses it. Okay, inserter arm, inserter arm, inserter arm. How do you run? Are you in radians or are you in degrees? Clamp to 360. The weird thing is the inserter arm works. So what am I missing here? Okay, so let's go back to Euler angle. And let's check what this does. It has to be in radians. And our system determines... I mean, anywhere in here does it say it needs to be radians? I feel like we're going to break so many different functions. Yeah, everything in here assumes we're running, I don't know why that's there. Everything in here assumes we're running on degrees. Because you wouldn't math off floor radian, because radians are usually pretty small values. So I'm not sure what at all happened here. We're assuming things are done a certain way. We're gonna close this. That way I can just rewrite all this code to my heart's content, start deleting things, and rewrite things. Do we have a radiant call method? There probably is one down here somewhere. We're gonna make one. Actually, that's not what we want. No, I did want to get rid of that. Where's our get methods? Right, set methods. Why is there no get method? We're gonna have one. Make sure that is the correct rotation. Yep. Apparently, it's already implemented. I just don't know where. So supposedly there's a get, or there's a, actually it's probably at the bottom, I'm just being retarded. Yeah, right here, there. So, we're just going to have to go through and do what I did the other day and test the snot out of things and ensure we didn't break anything. What we got recording time? We're at 30 minutes, okay. It is unfortunate that I have to do all this. It'll fix it though. So we want yaw 2 radians. And yeah, we just keep going through here. Pitch, radian. Keep in mind the 2 pos thing does not take into account roll. Roll is not actually really used anywhere. Something tells me this is probably broken. 2 axis angle probably doesn't work properly. Oh, this whole SCAS is right. Yeah, this is the one that uses the matrices, by the way. Okay. Could explain why my I've never been able to use the ray trace properly when it comes to players. Is that this whole system probably is broken. Hopefully it works. We can double check this math real quick because the sentry gun's calculate bullet offset is basically the same method. So it goes cos minus sine, and this goes cos time. Hold on. Oh, come on. Separate off separate window. Come over here. Do this. Do that. Thank you. You didn't stay at all where you were at. This is where oh, you're in the wrong package. That's why. Okay, so yaw minus radian yaw. We're doing sine times cos to get the x. Then pitch is just sine. It's different math, but does it get the same result? If it doesn't get the same result, I may copy this, because we're getting good results out of this. Maybe. But then I think this is correct. It's just it wasn't in radians, which is why it doesn't work. The 2 quantarian probably works. This is probably how I've been using it. I've been calling transform instead of 2 pos. Transform is where you take a vector. Say you were pointing 10 to the north and now you wanted to rotate right. You would call it transform instead. and it works a lot better because the Quaternion system does work. And yeah, this does a 2 radiances. Yeah, this whole system assumes we're running this, so this is just corrected. And did the Quaternion have a 2 positive? I'd be surprised if it did. It does. It has a transform, so we could pass in a transform of 1, and it would work. It'd be a little dumb, but I need to convert this to Java. Stupid thing is, I wrote the Quaternion class if we open it up. I already did. No, this is for some reason this is chicken bones now. I don't even want to know why. This is probably I am actually baffled by this now. Because I remember when we made Resonant Engine, I wrote a Quaternion class because I was so amazed by how well it worked over using our existing system for the sentry guns, and it made it work really, really well. I'm under the assumption Calclavia must have found something wrong with it and went and grabbed chicken bones because he always copied code from chicken bones for some reason. I never got it. I didn't really complain too much. Oh well. We'll probably need to implement rule at some point. But let's see if we get a better result of this. I'm going to pop this back over here. And we're going to run it again. This is probably going to break a few things. I'm probably going to have to go fix my robotic arms and see if they work. Not that I think I tested that in the first place. The handhold position. Yeah, I don't think it was ever tested. So what's this here? Drop item? Yeah, I don't think drop item works. Flying blocks, we can test this in a bit. Spawn circle. The dumb thing about this one is, no matter if this is broken or not broken, this functions perfectly fine. Because if you break your rotation value, all you did was maybe transition it by like 2 or 3 degrees, etc. What is going to really be screwbally is when we start doing things, we look at stuff like this. Some of the ICBM blast stuff is, well, these are all particle spawn code, so this doesn't matter. Same thing with this is particle, that's actually for velocity code, that's spawn code, that's spawn code. This is not even used anymore. This is older code. I think we transitioned this to an effect system. Tile display didn't work to start with. I'm okay with that. So maybe not so bad of an impact. It does mean we probably should be using transform though. So we'll look at transitioning to that. That way we can take our bullet offset and we can go, okay, transform by this, and then instead of doing what we have been doing where we're getting our position and then we're getting our offset, we could just transform our offset, because I think we have to do that anyways. We'll check. Okay. I want to say I fixed it. So get rid of this class, that class, that class, that class, that class, that one, and that one. Okay. So, yeah, we're facing 180. So we're going to take us over here, and we're just going to rapidly debug this. So I want to face 90 degrees, and 90 degrees should be, I believe, 10. If it's not, it'll invert. Yeah, it inverted. It should be negative 10. Damn, it's working now. So we want to get rid of all of our dumb debug here when it comes to forcing in the direction. Okay, we're 180 degrees off from center point. That's probably because our bullets spawn, maybe? What is the laser? That's our aim point, so that's where we're actually aiming. Everything else is based on offset. So let's try this. Okay, that's correct now. So our aim and our current aim are 108 degrees. And I got poked somewhere. Okay, so we're... Oh wait, the magenta's even further off now. Huh. Okay, so when it comes to this whole math, because we fixed our trajectory system, I can get rid of this. So how this will work is we need a new pause. 0, 0, width. I believe negative width is how it actually has to be. Dot transform current aim. I think I can get rid of this. And we're going to reload it and we're going to see what happens. Okay, our bullet offset now matches our current aim. Now we're just 108 degrees off from our actual rotation value. That's north. So we know from passing in 0 rotation that the sentry gun is facing the right direction. Now what's going on is that I guess our aim point, which is calculating our current aim, is backwards, which is done somewhere around here. So we want to try center minus aim point and see what that does for us. Ooh, 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 is it working? Yes. Look at that beautiful thing. It may not look like much, but that's, look, all those ray traces are pointing pretty much in the same direction now. That means we know for sure that our debug is functioning. And we can see the little red laser run. Oh man, that's so cool. So that was a major bug that was in VoltsEngine itself, and it's probably been causing issues with other things. So let's pop this open and take a look at, oh shit, we don't have ICBM in here. I would say if we had ICBM here, we could test ICBM, but we don't. So we're not gonna do that today. That's doing its trick. I'm gonna set the minimum rotation bounds for before it fires to be a little different here. There is aimed check, and we want to do this real quick. So we want to divide our rotation speed by 2, and that'll give us a little smoother looking. IntelliJ derped me there. Still derping me, IntelliJ? Okay. There we go. Looks a little better on the aim. Much nicer. Much more believable. And we're going to call that a close. So it means a short episode, but that's pretty much been it. We just testing debug. Getting code to make sure it runs properly. Fixed a major bug. This is why I needed to have JUnit testing for that. I'm probably going to go take some time here and JUnit the living snot out of all my data objects just to make sure they give me the expected results. Because that's really bad. And we don't know if the pitch is running properly because the turret doesn't have the pitch up and down. So let's Since I can't pick block at the moment, we'll grab another one of these, we'll break him, and we're going to test the pitch right before we leave. It works. I mean, the aim vectors are not exactly, because you can see they're kind of converging on each other. The pink one is kind of the one that needs to be fixed a little bit here. The blue and the cayenne one look good. You know what? I may be being biased on this because what may be happening is, yeah, I think because we have an add on the high point on this, so this may be getting us not exactly the best results. I'm gonna say it's working because the yellow laser looks okay. These look okay. I need to build a laser that doesn't have that pulsating rotation to it. Because you guys see the pulsating rotation because it's rotating, it's then flaring, and then it's pulsating, and that's designed to give that pulsating laser look, which looks really nice. Yeah, we're good. So I'm gonna close this out. See you guys later.